right, I'm gonna say a little bit about the Engineering 3 class. First of all, welcome back everyone. Although these first 2 weeks, some of you will be face to face, some of you will be virtual, and just wanted to kind of touch base with everyone and give you an overview of some of the class stuff. So we're gonna have some classroom stuff here first, and then we're gonna get into more about what's going on in the class and what the topics will be and kind of what to expect. So, first of all, from COVID-19, we got to wear a mask covering both nose and mouth at all times while we're in the classroom. We're not going to have food in the class, and you need to stay seated where you're assigned. We're going to have seating charts. This is for contact tracing. I'm going to set it up so we're socially distanced as much as possible, but I also need y'all to minimize the amount you're moving around the classroom. So when you get to your seat, that's where you sit, and you need to kind of make sure that you're not moving around the whole classroom too much. And again, mask stays on whole class period, and make sure it covers nose and mouth. So some classroom environment stuff. Want to be respectful of each other. This needs to be kept a scent-free zone, so don't apply cologne or perfume while you're in the classroom. Just be nice around the computers. Try not to break them. They're expensive. Take care of them. We need them to last for all years and all the other classes that use them. You have 3 restroom passes per 9 weeks. Save it for emergencies. Use the restrooms on first floor. Don't want you wandering the building. And make sure if you're leaving class that you have a pass. So on to stuff about the course. Here's kind of what we're going to be covering. We got professional conduct and communication. Get units, notation, trigonometry, vectors, hydraulics, statics, beams and trusses, manufacturing, electronics, simple machines and gears, pneumatics, pumps and pump head, stress and strain, and quality assurance. So these are the topics we're going to be kind of hitting on. There's a bunch of them. So we're going to kind of look at each topic for a week or two and then move on to the next one. So if you wanted to go into an engineer, here's kind of some of the basic math that more or less you need. You'll need Cal 1, Cal 2, Cal 3, linear algebra, differential equations, and then you usually need some sort of engineering math as well. Most colleges require you to take all those. Some colleges, in addition to those, want you to take partial differential equations, sometimes probability and statistics. The junior or senior level one that you take after Cal 2, not the freshman level one that you get with after college algebra. So these are the ones that happen after Cal 2. Sometimes vector calculus. And if you're going to go computer engineering, they may want you to take discrete math. So kind of the math structure at a lot of universities. You have college algebra and pre-cal. And then once you get past pre-cal, you unlock kind of this calculus chain. And you also unlock some of the upper level algebra chain. So once you get through pre-cal, then you can take Cal 1 or linear algebra. Then after Cal 1, you can take Cal 2, Cal 3, diffie-q, partial diffie-q, real analysis, topology. This keeps going into like modern analysis and measure theory and stuff like that. Sorry, not modern. This goes into like measure theory and other stuff. Over here we got linear algebra, abstract algebra, matrix theory, and again this goes beyond into like modern algebra and some other things. Cal 2, there's a branch off. This is where you can get probability and statistics, and you need Cal 2 to take discrete math. And Cal 3, you can take vector cal. So if you're taking vector cal, usually they want you to take that. I think it's usually a co-requisite. So you're taking it at the same time as Cal 3, or it's after Cal 3. It depends on which college you go to. So I have these posted up on the Canvas, so you can read through all of this here. But basically, if you're going to be mechanical, electrical, chemical, biomed, civil, environmental, computer engineering, or material sciences, the green courses are ones that you're probably going to have to take. So probably have to take all the way up through differential equations and linear algebra. Yellow, some courses require you to take like partial diffie-q, vector calculus, probability and stats. And orange, if you're going to be computer engineering, usually, or sometimes they want you to take a discrete math class there. A lot of engineering programs, till you get through Calculus 1 and you pass Cal 1, a lot of engineering programs won't let you actually declare yourself as an engineering major or declare yourself as part of the program. So a lot of the engineering, some of the like physics also is kind of this way, where if you want to be part of the program, you need to at least pass this math class to be able to declare in the program, and then you go beyond that. If you want to be an engineering technician or technologist that has less math, most places want you to take up to at least Calculus 2. Some want you to take linear algebra and have you take the Cal 3 and Diffie-Q, and a couple others want you to take like probability and statistics, the one after Calculus 2 as well. So our course, what do we see in this class? This class is taught to a kind of an Algebra 2 level, so most of what we see is kind of the college algebra level with a little bit of stuff that gets into pre-cal. So it's kind of down here on the initial couple rungs of the math charts. And because of that, as the equations that we use in here, you'll see as you go further and get Calculus 1 and Calculus 2 and differential equations, you'll see a lot of the equations that we have are either special cases, or there's a lot of like, we pretend that something's frictionless or that this doesn't happen, or we make some assumptions that make the equation nice, but if you're trying to realistically model the situation, as you get calculus and Diffie-Q, you'll see that there's more to the picture, and as you get the math up higher where you can talk about the more complicated cases, then in engineering and your science classes will start. Now that you know Cal 2 or now that you know differential equations, we can kind of rephrase some of the equations you've seen before in terms of that. So I'd consider this what we would say a survey course. So we cover a bunch of topics, but we don't go super in depth on any one topic. So we're gonna, I think we start out in hydraulics in this class. So we'll start there and we'll do kind of looking at some equations from hydraulics and some things like that, and then we'll move on over to I think it goes into like free body diagrams next, things like that, statics, that sort of thing. So again, like as we go through the material, make sure that as we kind of note as we learn calculus, the way we approach these problems are going to be overhauled, because you'll learn more complicated forms of the equation that can do more than we can right now. So to try to keep the material somewhat interesting, I've tried to blend it with either like Python code or some stuff we're going to do on sheets in Google, and generate some graphs and stuff like that. So that'll maybe keep it from being just like a math class exactly. We'll kind of get some technology mixed together with it. We're going to be generating a lot of files in here. I think they got rid of the student network drive, and I think all you have available now is your Google Drive. So make sure you're uploading your files to your Google Drive, and to keep your G Drive from getting all messed up, you probably want to come up with some sort of system, use folders, use naming conventions, archive stuff that you don't need, like come up with some sort of system so everything doesn't just turn into a big mess up there. So give that some thought, and you probably want to figure out something for yourself there. Course materials, all we really need is a spiral to take notes in, and if you're at home, you'll use your Chromebook, and if we're at class here, we'll just use the class computers. Let's see here. So ePortfolio, I really encourage you all to get one of those if you haven't already. Here's some platforms that you could possibly look at setting a portfolio up in. So kind of think about what work you'd want to showcase in there. Don't put stuff that's like you just did, slopped through something and got a bad grade on it. Don't include that. Just include stuff that's your best work. Anything that we generate that includes the design process, you want to make sure you're including all the initial design steps and sketches and brainstorms on up to where you're maybe going and generating your prototypes. And later on in the course, I'll show you some examples of portfolios that you can kind of get some idea of what they look like, I guess. So we'll do that a little later in the course. Okay, so what I want to do for the real quick here, I want to look at Canvas. So once you get logged into Canvas, you'll go to this PRACT, Science, Tech, Engineer, Math. That is our Engineering 3 course. It'll drop you on this homepage. Go down to modules. Everything in this class is going to be in modules. When you click on modules, that'll drop you off over here where you have basically all the information that you need. We have notes, assignments. What I've done is for each week, like if you see here, we have 1, 2, 3 assignments for the week. Down at the bottom, I have a assignments turn-in down there. So I was trying to do it with them all within the, each time you do this, there's a place to turn it in there, but that was going to generate like a massive amount of grades in the grade book. And it also was going to get easy to get lost as kind of what's what here. So if you look at the bottom of each of these weeks, there'll be there's a quiz and then there's a assignments turn in down there. So just everything we do during the week, there's going to be 2 grades per week, and everything we do during the week gets kind of tossed in down there. I should say there'll be 2 grades a week unless we have a major project during that week, and then that'll be a 3rd thing down there. So if you want to get started on this, let's say let's look here and say we got unit converter. So I kind of talk you through with the video, Python unit converter. We'll click next. This basically outlines what you're going to do, what the assignment is I want you to do. So you'll go through and build the thing up. Then you'll go to modules and you'll turn it in down here at the bottom of week 1. Let's preview this so you can see. It'll say, all right, here's that Python unit converter. So you'll choose a file, upload it right there. And then when you want to go back and say, okay, I'm ready to do more stuff, go back to modules. And then you say, okay, I got done with my week 1 assignment thing there. Let's move on to the next couple. These little attendance checks for each day that you need to make sure that, like on 8/26, make sure that you, at some point in time, hop online and answer that. If you're in class, just make sure that you jump online and you answer that at some point during the day, and that'll get you your credit. It's just a little like I was present, true, false thing. And that's kind of it. If you ever get lost as far as where am I in Canvas, just come back here to modules, click on that, and that'll pull you back into back into where you want to be. Then after we finish week 1, you can collapse that and go on to week 2. And after we finish week 2, we can collapse that, and I'll probably reorder stuff where I'll pull like week 2 above week 1 in your class. But that's basically how to navigate Canvas, and you just be watching videos on what we want you to do, and then give you some time to go through and work it through. And whenever you get done with each assignment, just come down here to the bottom of that week and drop it off. So.